Welcome to this session. The question at hand is to indicate the inverse of the given relations, and then to determine whether the inverses and the functions and the relations given are functions or not. And then specify the range and domain in each case. So let's start with the first one, F. So solution, F is given by 1, 2. Next pair is 2, 3. Next pair is 3, 6. Next pair is 4, 8. So the inverse of this relation is denoted by this and is simply given by, now all first elements become the second elements in every pair and vice versa. So this will be 2, 1. This will be 3, 2. This will be 6, 3. And this will be 8, 4. So that is the inverse of that given relation, 2, 1, 3, 2, 6, 3, and 8, 4. Now, the domain of F is a set of all first elements in F. So we have 1, 2, 3, and 4. Range of F is a set of all second elements in F. So I have 2, 3, 6, and then 8. Now, domain of the inverse relation is given by the first elements. We have 2, 3, 6, and then 8. And then range of the inverse relation is given by second elements, 1, 2, 3, and 4. Now, from this one, you see clearly that the domain of F is the same as the range of F inverse, and range of F is the same as the domain of F inverse. Now, to determine whether the relation F or F inverse is a function or not, we check in each pair how every elements are defined. The first case. So the first going to F, we have 2, 3, 1, 2, 3, and 4. Now, since in F, every pair has distinct first element, then the relation F is a function. In this F inverse, this is 2, this is 3, this is 6, this is 8. All of them are distinct, so also F inverse is a function. So this is the explanation. So you say both F and F inverse are functions since no two distinct pairs have the same first element and different second elements. So that's usually the guiding principle. The first elements are what guides for relation to be a function or not. And then S was given as H, the second one, the relation H we have 2, 2, 3, 5, 4, 10, 0, 2, minus 1, 5. Now, the inverse relation, you just switch. Second elements become first elements and vice versa. So that is the inverse relation, 2, 2, 5, 3, 10, 4, 2, 0, 5 minus 1. And then the domain of H is a set of all first elements. So we have 2, 3, 4, 0 minus 1. Range of H is a set of the second element. So we have 2, 5, 10. Now, because we have already written 2, there's no need of repeating. And then we have also written 5. So this is the range. And domain of the inverse relation is the set of the first element. So we have 2, 5, and then 10. So 2 has already been written, 0 has already been, 5 has already been written. So this is the set. And then the range of the inverse relation. Second elements, we have 2, 3, 4, 0, and minus 1. You see domain of H is the same as range of H inverse, and range of H is the same as domain of H inverse. Now, to determine whether H is a function, just go to the every pair and identify the starting or the first elements. Now, since all of them are distinct, then you say H is a function. Now here, this is 2, 5, 10, but we have 2 repeating and also 5 repeating. So 2 is repeating, and this second element for 2 is 2, while this one is 0. So they're different. This 5 is repeating. The first one was 3. The next one is -1. So this is not a function. Because of that repetition of first elements and second elements have different values in those repetitions. So this is a function. So formally we say H is a function since no 2 distinct pairs have the same first element and different second elements. So that's why we are saying that H is a function, but H inverse it's not a function. Since 2 distinct pairs, since they exist, at least two distinct pairs with same first element but different second elements. I.e., the pair 2, 0 and 2, 2. Another one is 5, 3 and 5, -1. So that is why H inverse is not a function. Lastly, relation S is given by -1, 5, 0, 2, 1, 1, 2, 2, 3, 5. So the easiest thing to have is the inverse of the relation. So it'd be 5 minus 1, 2, 0, 1, 1, 2, 2, and then 5, 3. And so the domain of S, set of all first elements, so -1, 0, 1, 2, and then 3. And then the range of S, the set of the second elements, all second elements, five, 2, 1, 2 has already been written, so 5 has already been written, so this just what we have. And domain of the inverse relation, we have 5, 2, 1, 2 has been written, 5 has been written, so that's what we have. Range of the inverse relation is -1, 0, 1, 2, and then 3. Now, to determine whether each of these two is a function, just identify the first elements in each pair. Now, since this -1, 0, 1, 2, and 3, all of them are different, so this is a function. For this other one, we have 5, we have 2, we have 1, but there's a repetition of 2, there's a repetition of 5. So this is not a function. Since there are those repetitions, and in repetition like 5, where 5 is the starting element, this and this one here, the second element is different from this other one. Similarly, this 0 is not the same as 2. So formally we say S is a function since no two distinct pairs have same first element and different second elements. And then S inverse is not a function since at least they exist at least two distinct pairs actually we have 5, -1 and 5, 3 and 2, 0 and 2, 2 with same first element but different second elements. So that's how we solve that problem. Thank you.